working on rational functions part 5, and so we're going to basically graph from the symbolic representation. Again, this is giving you the graph, and I'm asking you to extract from that the equation. I'm just going to look at the graph. I'm not going to read the things that they have, the hints that they're giving me. I'm going to say, all right, there's a vertical asymptote at x equals 4. There's a horizontal asymptote at y equals 1. I'm just listing out all the different kinds of facts. The y-intercept is at 1/2, I suppose. You know what? I lied. I think I'm going to read the thing over here. And it says the function has a 0 at x equals 2. Alright, here we go. It doesn't tell us what the y-intercept is. Alright, and then the x-intercept I can definitely tell that's straight up 2. Okay, so the way I would do this thing is I would say, well, this has to be a fraction. The fraction has an x minus 4 over there in the denominator because that is what I get that information from my vertical asymptote. My horizontal asymptote basically says is I need to let this thing go off to infinity. This thing will end up tending towards the number 1. So I know that there's going to be an x and probably a plus or minus something over here, but I know that the biggest exponent on that x is probably going to be to the first power, because when I want to take this thing out, or when I basically let x go to infinity, I want it to have x over x, which is equal to 1. Now, to figure out exactly what goes over here in this top parentheses, you simply look for the x-intercepts. This says that x minus 2 is equal to my numerator because I get that information from the x-intercept. One other thing is, even though they didn't give us the y-intercept, I'm guessing that it's about 1/2, and you can tell so by looking at this. When you plug in x equals 0 for the y-intercept, you'll have negative 2 over negative 4, which is positive 1/2. There you go. So I'm betting that this is actually the equation of that. If you were to graph this on Desmos or something like that, then let's try that. Let's see. It was a simple fraction, and it was x minus 2, x minus 4. There we go. I'm going to get rid of that parabola right there. That's exactly what I see. Let me zoom in a little bit more. There we go. See, there's a horizontal asymptote. You know what? I'll throw those in. At x, our vertical asymptote at x equals 4, and a horizontal asymptote at y equals 1. And you can see that property right there. Let me just change this color. How do I change the color? Yeah, let's try this. There we go. So my horizontal asymptote, my vertical asymptote, and then this is how that graph looks. Yeah, let's try another one. Alright, this one right here. I'm going to do this one a little bit quicker. I got vertical asymptotes at 4 and negative 5. So I have a denominator, and it's going to have an x minus 4 and an x plus 5 on the bottom. That's from the vertical asymptotes. I know that my horizontal asymptote is at x equals 0. I know that it looks to me like my x-intercept is at x equals 2. So I'm just going to throw in an x minus 2 over there. I have a feeling that I want to keep this. I don't want to add in another parentheses. Well, the reason being is because I don't see any other x-intercepts, so I'm going to keep that there. Also, I want this thing, if I want to take a look at how this horizontal asymptote looks, the big factor over here, this thing is approximately equal to x, and the leading term on the bottom is x squared, which is reduced to 1 over x. And if you look, 1 over x, the graph looks like this. And that's kind of how my graph is going. So I think that this thing is good right here. Let's look at the vertical, or the y-intercept, and see if that gets anywhere close to what my graph shows. This would say negative 2 over negative 4 times 5. So that would be negative 2 over 20, or negative 20. That would be 1/10. All right, it crosses at a really small number, 0.1. That's about right, because that would be there. Um, Dude, I think that we got the graph. Now, let's see. Let's try graphing that. It was x minus 2, x minus 4, x plus 1, x minus 2, x minus 4, x plus 5. Oops. X plus 5. There was a parentheses here. X minus 4. Sorry. There we go. See, that's my graph. And I need one more asymptote. And that would be at x equals negative 5. There we go. Let me change the look of that graph real quick. Or the color of that thing. Alright, now when I ask you to input, oh, I'm sorry. This is supposed to be at y equals 0. There we go. So let's look at some ideas about this thing. The horizontal asymptote can be crossed, it can be touched. It's not something that is untouchable. It just needs to have that graph eventually go towards that line in the ends. The vertical asymptotes can never be touched, and so you can see that these things, spike up and spike down and spike down and spike up over here. Let's see. Another thing that I need you to do is there's one more step. Even though this is the correct answer, there's one more step I want you to do, and it's just the way that I need to be able to put the information into the computer. I want you to FOIL out everything on the bottom and on the top. So on top I just have x minus 2. On the bottom I would have to FOIL this thing, and so that would be first, outer, inner, last. That would be x squared plus 5x minus 4x minus 20. So I simplify that to x minus 2 over x squared plus x minus 20. And then I ask you to compare that to this quadratic, I don't know, standard quadratic thing. Ax squared plus bx plus c over dx squared plus ex plus f, or something like that. So all I need you to do to input the answers is to input the coefficients. On the numerator, there is no x squared term, so a is equal to 0. A is equal to 0. B is equal to 1 because there's a 1 implied over here. C is negative 2. D is 1. E is 1. And F is negative 20. So that's how you would input the answer. I did that. The reason why I'm making you do this extra step is because this is probably the best way to standardize the way you input it. Even though I admit to you that the easiest form to use and to do is the factored form already, I do want you to put it into the standard form. It also gives you practice with foiling, which actually you need to get really good at if you want to do this stuff very quickly. All right, let's try this.